Hello, greetings to you all, and I'm so excited to come your way once again with another calculus tutorials, and this is going to be the last part one. So we are going to talk about integration using the trigonometric substitution. Yes. So after that, then we'll talk about the integration by parts, and that will be the last video I'll make under calculus. So let's proceed. Today's lesson is going to focus on the integration using what? Trigonometric substitution, right? So before then, I'll be happy if you join the Telegram page where I'll be posting more questions this week on calculus for you to solve them. Yes, so that you'll be able to pass very well. And also, don't forget to subscribe to my channel, right? So let's move on straight away. Before we dive into the integration using the trig, let's revise on a little like formulas on trigonometric, right? So we are going to talk about trig, some formulas that we need to know, right? Yes, so we are going to talk about trigonometry, right? Yes, so in senior high school, right, we can recall that sine, sorry, so you can recall that sine what? Sine A plus B, right, equals to what? Sine A cos B, right, plus cos A sine B. It's very, very important. This is one of the formulas that you need to know. Do you get it? Then number two, right, the opposites. Let's say sine A minus, right, B equals to what? Sine A cos B, right, minus cos A sine B. Please, at this point, always like pay attention very well. Like with all these formulas, all this proof, because they are really going to help you in the integration. So I will be happy even if, let's say, you pick your pen and your paper and jot down some of these formulas. Are you okay? Because it's your duty to memorize them. I'm not going to give it to you at the exam hall. So you need to memorize them, understand them very well. Then at the end, you will be able to integrate using the trig very well. Are you okay? So let's move on to number 3. That is the cos of it. If I have cos A plus B, right, that one becomes cos A, sorry. So that one becomes cos A cos B cos A cos what? Cos B plus. So it changes, the sign changes. Okay, sorry. Once we are using plus, right, it becomes minus. So the sign here changes. So minus sine A sine B. Very good. And if I have, how do you call it? Cos A minus B is simply going to be what? Cos A cos B, right, plus sine A sine B. Yes. So these formulas are very important. We are still moving on. I'm going to show you all the fundamental formulas. Then out of it, we'll be proving some formulas, right? So number 5 is if I have, let's say, tan A plus B, right? Then this will simply be what? Tan A plus what? Tan B, all divided by what? All divided by 1 minus tan A tan B. Are you okay? Yes. And also number 5 or number 6, if I have tan A minus what? Tan B, right? It's going to be tan A minus tan B, all divided by what? All divided by 1 plus tan A tan B. Yes. And the last fundamental formula, that is if number 7, if I have cos squared A, right, plus sine, right, plus sine squared A, then at the end I'm going to get 1. You get it? Take note of this, right, that if I have sine squared A, right, it's the same as sine A all squared. So you should take note of it. Or let's say cos squared A is the same as what? Cos A all squared. Okay, so you should take note of that very well. So these are the 7 fundamental formulas in trig. And out of it, we can get a lot of formulas. So let's take an example. For instance, if I'm asked to find, let's say, sine 2A, right? I know that this is going to be what? This is going to be sine A plus A, right? So sine A plus A is going to be sine A cos what? Cos A, right? Plus sine B, so plus sine A cos A again. Sine A cos A, right? So you see, this can end up becoming what? 2, because I can add this and I'll add this, and this will give me 2 sine what? Sine A cos what? Cos A, right? Yes. So sine 2A is the same as what? 2 sine A cos A. Do you get it? If I have, let's say, 4A, right? With this one, what I'm going to do is that I'll just increase, how do you call it? The angle, the value of the angle. So sine 4A, we are going to get 2 sine what? Sine 2A. So sine 2A, right, plus cos 2A. So we just increase the angle if we increase, how do you call it, the angle over here. So how do you call it? If you have sine 8A, right, sine 8A is simply going to be what? 2 sine 4A plus cos 4A, right? You should take note of it. So once I increase the angle with a multiple of 2, what is being affected is what? Is the angle within the results, right? So it just increases also with multiple of 2. Are you okay? So we should also take note that cos 2A, if I have cos 2A, right, if I have cos 2A, what do I get? It's simply going to be what? Cos A plus A, right? And this is giving us cos A minus sine A sine A. So this is the same as cos squared A minus what? Minus sine squared A. And out of this, we can get a lot of formulas. We are going to use this a lot in our questions. This formula can be used a lot in the integration, so you should take note of it. So at this point, right, I can replace the cos squared with what? With this. That is equation 7, right? I always know that cos squared A plus sine squared A is equal to 1, right? So if I want to make cos squared a subject, then in this case I'm going to get cos squared A is equal to what? 1 minus sine squared A, right? So with this, I can substitute it into this equation. Let me call it equation 1. Then what do I get? I'm going to get cos 2a is equal to what? 1 minus sine squared a minus what? Sine squared a. And at the point, what do I get? Cos 2a is equal to what? Is equal to 1 minus 2 sine squared a, right? Yes. If I also want to make cos the subject, like instead of sine, if I want to make cos the subject instead of sine, I'm going to get sine squared a is equal to what? 1 minus cos squared what? Cos squared a. So I can substitute it into equation 1 again, which is this one, right? So substituting it into equation 1, I'm going to get cos 2a, right, equals to what? 1 minus, or let me write the cos first. So I'm going to get cos squared a minus what? 1 minus sine squared a, right? Yes. And at this point, no, sorry, is cos squared a. Let me clean it. So I'm saying that, right, if I have cos 2a equal to cos squared a minus sine squared a, right, I can make sine squared a the subject over here and place it into what? Into that equation. You get it? That's equation 1. So I've made the sine squared a the subject over here, which is 1 minus cos squared a. So at the end, if I should substitute it into equation 1, what do I get? I'm going to get cos squared a minus, is going to affect it, right? Minus 1 minus cos squared a. Do you get it? And at the end, I'm going to get 2, let's say, cos squared a minus 1 plus what? Cos squared a. So I'm going to get 2 cos squared a. That is cos 2a is equal to what? 2 cos squared a minus 1. Right? Yes, you should take note of it. They are very, very important. These formulas are very, very important. And once you understand the fundamental formulas, you can find your way through all the formulas. Okay. So I've shown you the 8th formula, and probably this is the 7th formula. That's it. So let me consider this as the 7th formula. 7th, which have been manipulated to get other formulas. Okay. So let's move on. If I have, how do you call it, tan 2a, what do I get? Let's say 10. If I have tan 2a, then it's simply going to be what? 2 tan a, all divided by what? 1 minus tan squared a. Because the reason why we had this is because tan a is equal to what? 2 tan a is a plus a, right? And that is going to give us tan a plus tan a, right? All divided by what? 1 minus tan a, right? And this gives the 2 tan a, all divided by what? 1 minus tan squared a. So you see, all is coming from what? The point number what? Number 5 of the fundamental formulas. So the first 7 is the fundamental formula, and out of it we can get a lot of what? A lot of formulas. Okay. So if I have, let's say, tan 4a, right, then it's simply going to be 2 tan what? Tan 2a, all divided by what? 1 minus tan squared 2a, right? If it's odd, for instance, tan 5a, then the final result is going to be 2 tan what? Tan 5 on 2a, right? All divided by 1 minus tan squared 5 on 2a. You get it? You can work it out, and at the end you are going to get the right answer, right? So let's proceed. Let's proceed. So assuming I have, let's say, sine 3a, right? Sine 3a. Sake of the time, I'm going to just talk about the formulas and all those stuff. I'm not going to prove a lot, right? So if I have sine 3a, right, let me call this as, let's say, 12. Sine 3a is simply going to be what? 3 sine a, right, minus 4 sine squared a. We should take note of it. Then there's another set of formulas that you need to know, right? That is number 13. If I have sine a cos b, right, it's simply going to be what? Half into brackets sine a plus b plus sine what? A minus what? Minus b. Yes. And if I have, let me call it 14. If I have cos a sine b, cos a sine b, then it's going to be half multiplied by what? Sine a plus b, right, minus sine a minus b. Do you get it? Then if I have cos a cos b, that is 15 cos a cos b, then it's simply going to be half cos a plus b plus cos what? Cos a minus b. So you need to reflect on all these proofs. You get it? Don't worry yourself proving them, because our focus is not on trick, but just understand them, then you apply it in the trick, right? So number 16, if I have, let's say, sine a sine b, right, then it's going to be negative half into brackets cos a plus b, right, minus cos a minus b. Yes. And the last set that I want to show you is more like 17. If I have sine a plus sine b, right, so that will be the last set that we'll talk about. So sine a plus sine b is equal to what? 2 sine into brackets a plus b divided by 2 cos a minus b divided by 2, right? And with 18, if I have sine a minus sine b, right, then I'm going to get 2 cos x a plus what? Plus b, all divided by what? Divided by 2 sine a minus b, all divided by 2, right? Then the 19th part is 5 cos a. So we are going to talk about the cos of it. So cos a plus what? Cos b is equal to what? 2 cos into brackets a plus b, all divided by what? By 2 sine, or let's say cos A minus B all divided by 2. Then the last one, 20th, is cos A minus cos B. Cos A minus what? Cos B is simply going to be minus 2 sine A, right? Minus 2 sine X plus, or let's say A, sorry. So minus 2 plus A plus B all divided by 2, right? Then we have sine A minus B all divided by what? By 2. So that is it. So that is the 20 set of formulas I want to show you. Are you okay? Yes, so I'll encourage you to what? To go through all of them. It's very, very important. You're going to end all the tricks here, right? The next thing that you're going to do is solve more questions. So I'm going to encourage you to what? To go through all the trick formulas. Are you okay? Just take your time and go through them. Try as much as possible to develop a pattern to understand all of them. Are you okay? If not all, the key ones, which I said most of the questions always come from what? From the number 8, the 8th one and the 7th one, right? These two, right? Most of the questions come from such area, right? So before we proceed, right, there is two things that I want to teach you, two formulas that I want to teach you. Let me say 3 of them, right? They are fixed. And you see, when I was doing the integration using the partial fraction, I told you that the third one, I cannot do it because there's a formula that you need to know. And once you don't know it, it will be very difficult to explain to you. Okay. So this is phase. I've not proved it, and I've not sat down to prove it, right? So you should take note of it. I'm going to solve a question where I might apply it. Okay. So if I have, let's say, the integration of 1 on what? On square root of a squared minus s squared, right? Then the solution to this is giving us sine inverse of what? X on what? On a all plus c, right? Yes. With this, we made some substitution, and the substitution that we made was that x equal to what? A sine, let's say, theta, right? So this was the substitution you make. If you are proving it, right, you make a substitution of the x where x is equal to what? A sine theta. But this is the result. Once I have an integration of 1 over what? Square root of a squared minus s squared, then the result is going to be sine inverse of what? X over a plus c, right? Also, if I have integration of square root of a squared minus x squared, then this is going to be quite complicated. The result is a squared on what? On 2 sine inverse of what? Of x on a, right? Plus x on 2 square root of what? Of a squared minus x squared, right? Plus c. Yes, that is if I have an integration like this. So these are so special, right? And the most important one that I'll talk about, that I'm going to use, right, more, is that if I have the integration of what? Of 1 on, let's say, a squared plus x squared, then you are going to get 1 on a, right, tan inverse of what? Of x on what? On a, right, plus c. So with this, the third one is so important to me, right? Without it, it will be very difficult to solve type 3 of partial fraction. So if you know this one, then it will be easy to solve type 3 of partial fraction. You remember when we got there, I told you I'm not going to tackle the type 3 until I teach you the trigonometry substitution, right? So you need something like this to be able to solve type 3 of partial fraction. So take note of it, that if I have integration of 1 on a squared plus s squared, then it's going to give me 1 on a tan inverse of of x over a plus c, right? So this 3, I don't know where you are going to meet this and this, right? I don't actually know. I've not investigated on where you can meet it. Probably maybe you might meet exams where you need to apply the 2 above, right? But if it's partial fraction, you need to apply this. That is the type 3 of partial fraction. It's very necessary to know this. Yes, that is when we have the non-repeated quadratic function. Yes, so you should take note of it. It's very, very important. I'll solve one question under it. That is, we are left with about 30 minutes. So the last 30 minutes, I'm going to solve questions under the trig. Then after, I'll solve one question under this. Then we'll call the lectures a day, right? I'm going to call this lectures a day. And we'll be left with my last video on calculus, which will definitely drop on Sunday. Okay, that will end the week. So let's break for now. Let's go for a break. You get it? When I come back, I'm going to solve more questions on trig. So reflect on, how do you call it, on the formulas. All the formulas here, reflect on them. It's very, very important. Once you know them, your way of solving integration using trigonometry is so easy. Are you okay? So I wish you the best of luck with this break. I'll come back and solve some questions. All the best. All right, welcome back from the break, right? And you're going to solve some questions where we apply the trig rules, right? So, for instance, let's take example 1, right? Example 1, and the question is asking us to determine the integration of cos squared x, right? Dx. So solution, right? So integration of cos squared x dx. But I should take note, you remember, or if you can recall, we said that cos 2x, right, is equal to what? Is equal to 2 cos squared x minus 1. That is the rule. I made it clear to you that you'll be using this one often. Yes. So if you should look at all the proof that we did, right? We said cos 2a is giving us what? 2 cos square a minus what? Minus 1. Yes. So in that case, we can apply it in our question here. Okay. So we can make cos squared the subject in this relation. So with this one, cos square is going to be what? Let me send 1 to that side first. So I'm going to get cos 2x, right, plus 1 is equal to what? 2 cos squared x, right? So with this, I can divide both sides by 2. 2 here and 2 there, right? So in that case, what do I have? I have cos squared x equal to what? Cos 2x plus 1. Very good. So now that I know that cos squared x equal to cos 2x plus 1, then I can simplify something like this, right? So I'm going to get integration of what? Cos 2x plus 1 with respect to what? Dx. You get it? So I can break this one down to something like this. Are you okay? So once that I've been able to break this one down to this, it's going to be easy. Sorry, divided by 2. I need to bring the 2 there. So all divided by 2. Do you get it? Yes. So simply, let me write it again. I have integration of what? Cos x dx is the same as integration of cos 2x plus 1 divided by what? Divided by 2 dx. Yes, perfect. So now I can just integrate this side. This side is very simple to perform integration, right? Compared to what? Compared to the cos squared 2x. So cos squared 2x is very hot, difficult, but if I'm able to break it down to this form, then it becomes easy. So now let's integrate this. So with this, I'm going to bring the half out. Half integral of what? Cos 2x plus 1, right? Dx. Okay. And this one can also be further breaking down to something like this. 2 or into bracket, right? The integral of cos 2x dx, right? Plus integral of what? 1 dx. Because last time I made it clear to you that if I have integration of what? Ax plus bx or dx, right? Then we can perform distribution, which is integral of ax dx plus bx dx, right? The same applies to this. So we can perform what? We can perform integration, right? Distribution for all of them, and we'll get something like this. Now it's very easy to simplify. I have half into brackets cos 2x. What do? We differentiate what is inside, right? If I differentiate what's inside, what do I get? I'm going to get half. That is 1. Sorry, I'm going to get 2. So differentiating, sorry. So differentiating of, how do you call it? 2x is going to give me what? 2, right? So if I get the differentiation, then it becomes a fraction of it. That is 1 over the 2. Do you get it? Yes. Then I now change the cos to sine. It's going to be sine. Then I just repeat again, 2x. So that is the integration of cos 2x ds. Yes, if you are struggling with it, watch my previous video and you get the concept. Plus, and this one, 1x is the same as x exponent, so it's 0. Right. So it's going to be x exponent 0 plus 1, all divided by what? 1. Do you get it? Yes. So plus c. So now it's very easy to simplify. So what do we get now? We are going to get half sine 2x divided by what? Divided by 2 plus x, right, plus c. And this gives the final results, right? So when you are using the trigonometry, it becomes easy to what? To simplify. Are you okay? Let's focus on another example. We've done sine 2x, right? Let's integrate cos 2x. This time I'm going to be quite brief, right? So we should determine sine squared x. That is example 2. I'm asked to find sine square x of what? Of dx. Right. This time too, we can use the cos 2x, but we'll be replacing what? The cos with sine. This is what I mean. We know that cos 2x, right, equals what? 1 minus 2 sine what? Sine squared x. This relation is also there. Yes, we did it. We talked about it. So please, if you are struggling with, how do you call it, the integration using trig, please try as much as possible to understand the trig rules and you find your way out. So you see, cos 2x is the same as what? 1 minus 2 sine squared x. So we can use that relation. So here is it. We've written it here nicely, like cos 2x equal to 1 minus 2 sine squared x. So I can make sine squared a subject in this relation, right? I'll first send 1 to that side. And I'm going to get cos 2x minus 1 is equal to what? Minus 2 sine squared x, right? Let me make the sine square positive. So I'm going to send all the sine to this side of the equation and all the cosine to the other side of the equation, right? So what do I get? I'm going to get 2 sine squared x equal to what? The positive. 1 is going there, so 1 will be positive. Minus cos 2x, right? So that is 8 for the simplification here. Now we can make sine squared the subject. I can make the subject by dividing both sides by 2, right? So I divide here by 2 and I divide here by 2 so that it will cancel out. And I'm going to get sine squared x equals to what? Half into bracket 1 minus cos 2x, right? So for this case, right, I can just do what? Bring it over here. So it's the same as integration of what? Half into bracket 1 minus cos 2x or dx, right? So I can bring the half outside the integration symbol. So I'm going to get half integral of what? 1 minus cos 2x or dx, right? So what do we have? Now I can expand the integration sign over here, right? How do I expand it? I'm going to get half. Let me use an orange color to show the external brackets, right? So half, then I have integral of what? 1 dx minus integral of what? Cos 2x dx. Very good. So the integral of 1 is x. We've already witnessed that one. The integral of 1 is dx. So what do we get? We are going to get x minus, then how do we integrate this one? We first differentiate what is inside and make it a fraction as a coefficient, right? So we are going to get the differentiation of 2x is 2. So we are going to get 1 on what? On 2. Then the cos will be changed to sine. So sine what? 2x, right? So we have plus c outside. So at the end, if you simplify this, what do you get? You are going to get x, or let's say half into bracket what? X minus sine 2x, all divided by what? 2 plus c, right? Once you get this, you can manipulate it in any way that you want it to get your final answer. So you can rewrite your final answer in any form. So that's the integration of sine what? Sine 2x, sine squared x. Sorry for misinterpreting the sine squared s and the sine 2x. So this is the integration of what? Sine squared x. Are you okay? Okay, let's proceed to example, how do you call it? 3, right? So I'm also going to find the integration of what? Tan squared x, right? So tan squared s dx, right? When you see it like this, you might think that, oh, it is very easy to what? Simplify by trying to bring the square outside and what? And manipulate it. But trust me, it's not easy like that. If you don't understand the trig rule, it will be very difficult. So when you are doing something like this, just take your time. Okay, take your time and try to know the trig rules. Then you'll be fine. Do you get it? So solution. What do we have here? We can apply this rule. We know that 1 plus tan squared x is equal to what? Sec squared x. Why is it so? Right. It came from the cos squared x plus what? Sine squared x is equal to what? 1. Let me divide all the side by what? By cos squared x. So I'm dividing here by cos squared x, dividing here by cos squared x, and dividing here by cos squared x, right? This will give me 1, right? Plus sine on cos is tan, so tan squared x equal to what? This is sec squared x. Yes, so that is where we had that rule, right? So you need to know this if you want to integrate, how do you call it, the tan square x. So with this one, I can make tan the subject, tan square x the subject here. So tan squared x is equal to what? Sec squared x minus 1, right? So I can substitute it into the relation. That is integral of tan squared x dx, right, is equal to what? The integral of sec squared x minus 1, right, dx. So this is the same as integral of sec squared x dx minus the integral of what? 1 dx. But if you can recall, in our first video, we set some standard integration. That is, if I have the integration of what? Sec squared x, right? We made it clear that integration of sec squared as, even let me make it as, integration of sec squared ax, right? That's the rule that we set. So integration of sec squared as. We made it clear that if I have this and I'm integrating, right, I'm going to get 1 on what? On a tan ax, right, plus c. Yes, that is the rule that we said we are going to get. So if we should apply the same to this side, then it means, what are you going to get? We are going to get 1 on what? On 1. Do you get it? We are going to get 1 on 1. That is, if I should integrate, a is here, a is 1. So 1 on 1, tan what? Tan 1x, which is the same as x. Do you get it? Yes. So 1 on tan 1x. So we've been able to integrate the sec square x. Then minus x, if you should integrate 1 dx, we have plus c. So at the end of it all, what do we get? We are going to get tan x minus x plus c, right? I'm not saying that you cannot use other technique to solve it. Here, you can use another technique to solve it, but it's going to be so complicated, right? It might be complicated. Let's see. I'm going to show you another alternative, but I'm not going to solve it completely. If I have tan squared x, right, integration of it, I'm going to say that it's integral of what? Sine x on what? On cos x all squared, right? Which is going to be quite complicated and a whole lot. So if you know the trig rules, it's going to save more time. You get it? So try to know the trig rules and try to what? To be solving questions under it. Then you'll be fine. Let's talk about another example, right? So assuming I should find what? this example, what example are we now? Example 4. Very good. So example 4, right? They say I should find the integral of what? Of cot squared x. Right. So cot squared x. So solution. So I want to find what? The integral of what? Cot squared x. So before I solve that, I need to use this rule, right? What substitution can I use here? I can say that cot squared x plus what? Plus 1 equal to what? Cosec squared x. Let me expand the space there and write it well. The space is too small for me. So let me expand the space well. That is my jotter, more like a jotter to me. So we can say that it is the same as what? Cot squared x, right, plus 1 equal to what? Cosec squared x. The same applies. We are still using the cos x squared or cos squared x plus sine squared x equal to what? 1. Right? I can divide this side by sine x, that's sine squared x. Divide here by what? Sine squared x, and divide here by sine squared x. Right? So if sine over cos is tan, right, then it means that cos over sine is inverse of tan, which is cot. Cot is just inverse of tan. That's the reason why we have the cot square x plus the sine cancel itself out. Then we have 1 is equal to what? Cosec squared x. Right. So with this, what do we have now? With this, we can do what? Make cot squared x the subject, which is very simple. So cot squared x is equal to what? Cosec squared x minus 1. So we can substitute it here. This is the x, sorry. So it's the same as integral of what? Cosec squared x minus what? 1 or the x. Right. So with this, I now have integral of cosec squared x. Let me expand it straight away. I'm expanding the integral symbol. So cosec squared x dx minus what? The integral of 1 dx. So that is it. And you can also recall that in our first video on standard integration, we said that integral of cosec squared ax dx, right, is the same as what? Is the same as minus 1 on 2 cot ax, right, plus c. Right. So out of this rule, we can use to integrate the cosec squared x. Right. So the a here, this one we are going to get minus 1 on 2, right, cot, then the a is 1, so cot x, right. Yes, very good. Then we have minus x, we are done with this one, and the minus is for the 1 dx, right, minus x, then plus c. Do you get it? Yes. So that is basically going to be the integration, or the integration of cosec squared x dx minus 1. Are you okay? Yes. So that is for, how do you call it, the integration, right? I was about to say any question, but I've forgotten that I'm not in class. So let's continue. So if you have any challenges, if you have any question, please try as much as possible to link up. Are you okay? If you see any mistake anywhere, try to link up. And if you don't understand anything too, try to link up. Then I can go through it with you. Are you okay? There are more complicated ones that time will not permit me to solve here. But I want to solve the fundamentals with you so that you get the concepts. So if you have a challenging one and you want me to assist you, just share with me. I know that this one is very difficult, frankly speaking. Among all the integration, for me, right, it is the trigonometry integration which is very difficult, right? So you need to memorize a lot, set a lot of memories and all those stuffs. So try as much as possible to solve questions under it. Okay, I've given you the brief overview. So just take it upon yourself to solve a challenging question. Then you will find yourself in a good situation. Okay, at this moment, let's solve some last example, right? Which combines the partial fraction and some aspect of the trig. Do you get it? What I wanted to tell you. Okay, yes. So let's do that. So assuming I'm asked to integrate, right? Integrate 3 plus 6x plus 4x squared minus 2x cubed, right? All on what? All on x into brackets x squared plus 2 plus 3, sorry. So x squared plus 3. Very good. So with respect to what? Dx. So with this solution, right, I'm going to first make sure that I break this down with a partial fraction. So let's do that. So I have 3 plus 6x plus what? 4x squared minus 2x cubed, right? All on what? All on x into bracket x squared plus 3, right? This, we have s squared, sorry. So this is s squared. We get it. So that's how the questions look like. Yes. So with this one, let me verify again. We have 3 plus 6x plus 4x squared minus 2x cubed, all divided by x squared into brackets x squared plus 3. So with this, right, if I should write the general form for the partial fraction, it's going to be a on what? On x, since it's a repeated function, it's going to be another b on what? On x squared, then plus we have cx plus d, all divided by what? X squared plus 3. Yes, so that's going to be the general solution for the partial fraction. Okay. So at this point, I can simplify what is at the left hand side, right? That is, I have x squared into bracket x squared plus 3, right? So it's identical to the identical symbol. So with this one, I'm going to have a into brackets, right? X multiplying what? X squared plus 3. Yes. If you want to know the common factor, you just write the denominator x squared into brackets s squared plus 3. Then you divide it by the denominator of the a alone. So the answer that you get is what is the common factor which will be multiplied with the numerator. We get it? Yes. So plus b into brackets. With this one, if I have squared, I'm going to get s squared plus 3. So I'm going to have here s squared plus 3. Very good. Then plus cx plus d. Right. Let me put that one in the brackets. Cs plus d, all multiplying what? It's multiplying. If I have the s squared plus 3, it will cancel out. So it's multiplying what? X squared. Very good. So at this point, I can simplify further by having what? The ax into brackets x squared plus 3. Let me do it little by little so that it will be clearer. Then we have plus what? Plus bx squared plus 3b. That's expansion of this, right? Then plus, left with this one, I have cx cubed, right? Plus dx squared. Very good. All divided by what? X squared into bracket s squared plus 3. Very good. So what again? I can simplify the a side now. I'm going to get ax cubed plus 3ax plus bx squared plus 3b plus cx cubed plus dx squared. All on what? All on x squared into bracket s squared plus 3. So now they are now identical. Very good. Right, they are the same. So let me repeat this one. I have 3 plus 6x plus what? 4x. 1 is squared. So 4x squared. Right. So 4x squared minus 2x cubed. All on what? All on x squared into bracket s squared plus 3. So at this point, we can compare the numerators, right? Since they are identical, we can compare the numerators. You are going to get 3 plus 6x plus 4x squared minus 2x cubed is identical. Is equal to what? Is equal to ax cubed plus 3ax, right? Plus bx squared plus 3b plus cx cubed plus dx squared. Right. So at this moment, right, we can group the terms at the left hand side. We are going to get a s cubed and c cubed, right? I always prefer using a different ink so it will not confuse me. So I have ax, that is ax cubed plus cx cubed, right? Then for the x squared, for the squared, right, I'm going to get plus what? bx squared plus dx squared, right? Then for the x values, let me use red. Okay, so plus ax, and that's all, plus 3ax. Then the last one for the constants, right? With the constant, I have, how do you call it? That is 3b. So plus 3b. Sorry, my 3 looks like b. So let me write it again. I have 1, 2, 3, 4, 5, 6 terms. So I need to get 6 terms. That is 1, 2, 3, 4, 5, 6. Very good. So at this point, I also know that the constant is 3. Then we have, how do you call it? The s value, which is plus 6x. Right. Then we also have the squared, which is plus 4x squared. Then we have, how do you call it? The cube, which is minus 2x cubed. Right. So let's proceed. We can factorize each of the terms over here. So factorizing each of the terms, I have what? A plus c into bracket what? X cubed, right? And I also have plus b plus d into bracket what? X squared, right? Then what again? I'll get plus, that is 3ax, and I have my plus b over here, plus 3b over here, right? So now I can compare it with what is what at the right hand side of the equation. So comparing, I'm going to get comparing each side, right? That is for the constant is equal to what? The 3b. So I'm going to say 3 is equal to what? 3b, and that gives me equation 1. Then the x values, that is 6 is equal to what? 3a. 3a, that's equation 2. Then 4 is equal to what? B plus D. So 4 equal to what? B plus D, that's equation 3. The last one, minus 2 is equal to A plus C. Minus 2 is equal to what? A plus C. That's equation 4, sorry. So from 1, right, let's solve them. From 1, you can get 3 divided by 3 is equal to what? 3b divided by 3. So at this point, I can say that b is equal to what? 1. So what about 2? From 2, I'll say 6 divided by 3 is equal to what? 3a divided by 3, right? So I'm going to get a as what? 2. But from 3, right, I know that d is equal to what? 4 minus b, right? And that is going to give me 4 minus 1, and that ends up becoming 3. That is d. Then what about a? So from 4, I know that c, right, is equal to minus 2 minus a, right? And that one is more like minus 2 minus what? Minus 2, right? That will give me minus 4. So those are the terms. I have a being 2, c being, b being 1, c being negative 4, and d is, how do you call it? 3. We just substitute it into what? The main identity, right? So we can say that the 3x, right? Not 3x, but simply the 3 plus 6x, right? Plus 4x squared minus 2x cubed. X cubed, all divided by what? X squared into bracket x squared plus 3 is identical to what? It's identical to the a was 2, so we are going to get 2 on what? On x, plus the b was also x squared, so 1 on s squared, then plus minus 4x, very good, right, plus 3, all divided by what? X squared plus 3, very good. So now if you look at this side of the, how do you call it, this side, right, it can be split into what? Into 2. So we are going to get, it's identical to what? 2 on what? On x plus 1 on x squared minus 4x on what? X squared plus 3, right? Then plus 3 on x squared plus 3. You get it? Yes, very good. So now, to find a solution, we need to find the integration. Like, this was the question. We are finding integration of this. And since this left-hand side is equal to what's over here, so we can also find the integration of what? 2 on x plus what? 1 on x squared minus 4x on what? On x squared plus 3, right? Plus 3 on what? On x squared plus 3, all dx. So dx. So you can expand it over it. So at the end, we are going to get integration of what? 2 on x dx over here, plus integration of 1 on x squared dx, right? Minus integration of 4x on what? On x squared plus 3. Then what again? Then we will have plus or dx, right? Plus integration of what? 3 on x squared plus 3 dx, right? So at this moment, we can split it into what? Into different form, right? But if you should look at what is at this side, we're going to tackle this one. This one, you need to use the tan that I talked about. And this side too, you need to use the normal differentiation which you hold. All the rest, you need to use the normal differentiation which you hold. So let's talk about this side alone. That is, if I have integration of what? 3 on x squared plus 3 dx. You remember I made it clear to you in one of the, how do you call it? The questions. In one of the rules, that if I have, I'm going to scroll through so that I see it clearly. Yes. So if I have this one like this, that is 1 on what? A squared plus s squared is equal to 1 over tan. How do you call it? Inverse of x on a plus c. So that alone, we can apply that rule. So we can apply that rule over there to what? To solve that question. So that side alone, you can apply that tan rule. So how do you apply that one? We need to make sure that, how do you call it? We need to make sure the x squared and also the a is also squared. Because the rule says that all of them should be squared. Okay. So how can we square the a in this situation? Right. We can square the a by saying that this is the same as what? The integral of 3 on what? On s squared plus square root of 3 or what? All squared. Right. We can introduce something like this. And introduce something like this, it becomes easy to what? To integrate. Right. Dx. And this will be equal to what? That is 1 on what? On x squared. Right. Because the rule stated that if I have, how do you call it? 1 on what? On a squared plus x squared. Right. Integral of 1 over a squared plus s squared is equal to what? 1 on a tan inverse of x on what? On a plus c. So at this moment, sorry, a is rather the cube. Do you get it? So you are going to get 1 on square root of a. 1 on square root of a, right? That is 3. Sorry. So you see how complicated it is. So 1 on square root of what? Of 3, right? Then you are going to get the tan inverse of, that is the x over what? Over square root of a, right? Or square root of 3. I'm just trying to insert. So square root of 3, right? Then I'm going to get my plus c. So that's it for the integration for only that side. Right. So we have jotted it down. We are going to use it. Ayeki. So let's integrate this one. Let's integrate each step. So looking at the first step, right? If I should integrate it, what do I get? I'm going to get, let's write it 2 over what? 1 over x dx. That is going to give us ln x. Then this will be plus integration of what? X minus 2 dx, right? Then minus integration of 4x into bracket x squared plus 3, right, dx. Then I have plus integration of what? 3 on what? X squared plus 3 dx. I already know this, so when it gets there, I'll just insert because I've explained that one to you. So let's do that. You're going to get 2 ln what? Ln x plus, then what do I get here? It's going to be plus 1 divided by what? Minus 1. I'm going to get x minus 2 plus 1 all divided by what? Minus 1. That's if I simplify the 2. Then minus, what do we do here? We find the differentiation inside here. So the differentiation inside this bracket is going to give us 2x, right? So you're going to get 4x on what? On 2x, right? I explained this one last time, how we do that. So if you are struggling with it, go and watch my previous video on integration and you understand. So I repeat this one again, x squared plus 3, right? Then here is exponent what? It was exponent minus 1. I forgot to bring. Yeah, I think it's exponent minus 1. Yes, very good. So at the end, I'm going to get minus 1. Was it minus 1? Yeah, very good. So minus 1 plus 1. Right. So at the end, I don't need to even write this one because it is ln. I don't need to add plus 1 to it because when I said it was minus 1, it's going to be ln. So we are going to change this one to ln very soon. Then I have my plus, let me repeat this, which is 1 on root 3 tan inverse of what? X over what? Root 3 plus c. I've already done this. So what is the final answer here? I'm going to get 2 ln x minus, because the minus is going to counter. Okay. So minus 1 on what? On x, because I'm going to get minus x. When I simplify this, I'm going to get minus 1. So 1 on x. Then this cancels this one. So I'm going to get minus 4 on 2 ln what? Ln x squared plus 3. Then plus 1 on what? On root 3 tan inverse of x on what? Root 3 plus c. Right. So with this, I've already simplified out and I can rewrite it again so that it will be nice. So this one goes here 2. I'm going to get 2. Let me send all the ln to one side. 2 ln x minus what? 2 ln x squared plus 3 minus 1 on x minus 1 on root what? 3 tan inverse of x over root x root 3, sorry, plus c. So here you can use the log rule over here. You're going to get ln x squared, right, minus 2 ln what? S, no, not 2, but the 2 will be an exponential value. So minus ln x squared plus 3 squared minus 1 on x minus 1 on root 3 tan inverse of what? X on root 3 plus c. So at this moment, I'm going to get ln into brackets s squared all on what? X squared plus 3 all squared, right, minus 1 on x minus 1 on root 3 tan inverse of what? X on what? Root 3 plus c. And this is going to give us the final answer. You go through it. If there's any challenge, you let me know. Okay. I wish you the best. Today has been a long video. I wish you the best of luck. And today I'm going to make the last video on the calculus. That will be integration by parts. I wish you the best of luck. All the best. Bye.